Hello, our samurais, and welcome to our Samurai Lab lesson 4. Now, this is a remake of the other lesson because I noticed that the screen was not properly being recorded, same as with lesson 3. I apologize for that. I'll try to keep this video much shorter, and I'll try to comment on some of the things again that maybe I missed from the other video, or maybe I already mentioned them, but I forgot. In any case, I'll try to keep it much shorter. I'll be doing a lot less typing this time around because we already have here the content that we will be covering, and we'll basically just be explaining that content. I usually like to type it in these lessons, but because of time issues, right, and having to replace this content, I'll just be trying to stick to what we've done already to keep consistency with also the future classes and the content that has been shown in there, and not be creating this big gap in the content that we have. With that said, let's get to it. And once again, sorry for the issues, right? Sorry for that. Let's get right into it. So I'll be maximizing this. And I don't remember if I said it in maybe lesson 3 or which lesson I said it in, but you can also create section codes, right, like this one. And to do that, you type a hashtag, type some name, and at the end of it, you type 4 hashtags, and this allows you to organize your code in a very nifty way. Here you see some sections, right? So remember, you can do that. If you just want to comment things, you just need to add a hashtag there. So first thing we do, once you, of course, load any R session, is load the libraries, right? So actually, let me close this and let me open it from scrap so that you can see how that loading does. So we're going to load the tidyverse. It provides us with everything that's been loaded. Then reader, it doesn't really tell us it's loaded, didn't give us an error, but didn't really tell us anything else like the tidyverse does. And let's load OpenXLSX. Next, we'll load our CSV file, and after that, we'll go into manipulating data. This lesson will be focusing on basically working with strings and a little bit of just string manipulation. It's very important that you learn how to do this because sometimes you want to make searching with strings much easier. You remember last lesson we were looking at filter and how we can look at filtering information, and we said that yes, you can create some very complex filters, but then it requires a lot of typing. An easier way of doing it is actually with some other functions that we will be covering today that you can already see here. So I'm going to be uncommenting these 2 lines. And the first thing we will do is we're going to take our data set, of course, which is my first data frame, and we're going to be saving that into another data frame called data2. We're going to be calling my first data frame, then we're going to use the pipe operator, which we talked about in the previous lesson. Remember, you can use the pipe after loading the tidyverse. If you don't load the tidyverse or the magreadr package, you won't be able to use it. We're going to be going then into a filter. Remember, the first data frame is already being passed into the function filter without us having to do it. And then inside, we're going to use the function strdetect. What does strdetect do? Strdetect does the following. Actually, let's just type it. And it says returns a logical vector with true for each element of a string that matches pattern and false otherwise. Yeah, that was very cool, huh? But in other words, it'll basically just return true or false and make filtering very easy for us. So let's see how that looks like. So data2, we created data2 by using filter strdetect. Then we told it to go into our letters variable, our letters column, and look for the letter A or J or I. Well, A or J or C, sorry, this is not I, this is the OR operator. If you remember, we covered that in lesson 2. If you forgot about it, please go back to lesson 2 and look at it again. So we can actually just say like this, right? And then it'll just filter for A. But if we want to include others, we can use the OR operator. Now, if you remember from lesson 3, and actually we can open that, you can see that data 2 in here, data 1, you could also filter like this, right? You will need to type letters equal A, or letters equal J, or letters equal C. And that is a very long condition when compared to strdetect, where we said just strdetect letters A or J or C. So much more compact, much better, I feel. So this is a very nifty trick. I encourage you to use it and keep it. Next, we have, of course, other ways in which we can use strdetect. We can use strdetect with filter. With different operators. So this A, right? So it says from word to power operator A. What will that give us as a result? Well, let's find out. So doing that basically gave us all the words in the word variable that started with an A. So if you want to filter for something, a whole data set just for words that start with a particular letter, this is your guy, right? This way of doing it is the way, as the Mandalorian would say. But it doesn't stop there. strdetect has many other uses, many other tricks still up of its sleeve, under its sleeve. So another one is using brackets and then letters here, A, E, I, O, U. In this case, let's just change this instead of the vocals. The vowels instead of the vowels. Let's just look into, let's say, AE. And then all the words that contain an A or an E are there, but I think that was probably not the best way of doing it. Let's look better at P. Everything that contains a P in its name will remain. So you can use the brackets to specify letters that you're looking for. So that's also very useful. Now, it doesn't end there, right? You can also use, for example, a money sign. So let's see what that does. A money sign. And then we can see that it just filtered for the words that have multiple A's. In this case, it's just banana. The other words just have one A. So that's also very interesting if you want to use the money sign operator. To the letter, it'll just find everything that contains that. And that's basically the use of strdetect. You can use it in conjunction with filter. This combination is very powerful, and it allows you to do very amazing things when it comes to filtering your data. Now, the next function we're gonna be looking at is mutate. So I'm gonna doing this like this. And mutate allows you basically to create new variables, new columns. And you can create new variables in a single mutate call. You don't have to type mutate to create one column, then pipe another mutate to create another column or variable. You can just do all at once. So you can say mutate speed equal light speed. This will create a new column called light speed. So my first data frame doesn't have that, right? And we're gonna be doing that. Let me just comment this out so that we don't get the error. And then we should see that data 2 has a new variable called light speed. But it doesn't stop there. You can, like I said, you can create multiple variables within a single mutate call. And now let's do another one called total, which will be equal to number times value. So we have number times value. So let's execute that. And now we have 1 times 10 equals 10, 2 times 15 equals 30, 4 times 0 equals 0. Basically, we have created already within that single mutate call, which is pretty cool, 2 variables. But it doesn't stop there. We can continue doing very, very interesting things. And I'm going to be introducing yet another function for manipulating strings called substr, substring. Remember, if you want to look at the documentation of a function, you can type question mark name of function. And it says extract or replace substrings in character vector. Right, so we're gonna be using it to create another column, another variable called initials, and that will contain a substring of word. Word is our variable here in our original my first data frame. And then we're gonna be looking at first and last position. So first position is 1 and last position is 2. So that means that we should probably end up with a data frame that is called initials that will contain only the first 2 letters of word. So let's see how that goes. And there we have it. We have initials AP, BA, PE, PI, which are basically the first letters of the word. We can change this to 3. And then we will have 3 letters, and we can keep changing it. What happens if we go out of bounds? I think it probably doesn't tell you. So let's say that we have 1, 2, 3, 4 positions 10 and 11, which obviously don't exist. It won't give us any error, but once we go to our data frame, it didn't do any. There's nothing, right? It's just there's nothing in there because those positions don't exist. So let's go back to 1 and 2 and keep it like this: initials AP, BA, PE. So that's how you can use substring to quickly, extract strings from something. And when would you want to do this? You might want to use substring when you need to, let's say that you have 2 different data frames that have something in common, something at the start and something at the end in one of their variables. One way would be to create a new column that they have in common so that you can later join them. We'll go into how to join different tables at a much later lesson here at our SamuRai lab. Now, you can also replace strings, right? Let's do a string replacement. And that can be done with str replace. We can see that str replace, it says it replaces the first match, and str replace replaces all matches. So that's very, very important to remember, because sometimes you think like, oh, str replace, it's gonna replace everything. No, it's just gonna replace the first match of that. So here, let's say that we have, let's make it up to 4. Execute it. So here we're gonna be creating or modifying this. Actually, we're gonna comment this out. We're gonna be doing initials equal str replace. We're gonna be passing our string, which is equal to initials. By the way, you can also type like this. You can also say initials equal str replace, and then initials p with x. So these two here are exactly the same thing. One, we're being very specific about the arguments that particular function has, and we're passing down the same. Hey, strings is going to be initials, right? Which is well, we haven't. We'll have to create this one over here. Strings is gonna be taken from initials, right? And we're gonna be finding p and replacing it with an x, basically. Let's keep it to 1 to 2. Or you can pass it down as, like I said, you can write the arguments down that the function requires. In this case, str replace has string, pattern, and replacement. If you want to be very explicit, you can write it like this. If you're being lazy, you can also write it like this. So we're going to try both cases. So let me just quickly comment this one out, execute this code, and we should see that data, now where you used to have a p, now you have an x. But like I said, str replace replaces the first match. So if you have multiple p's, you wouldn't be seeing that. So let's just say that we have 5 here, 5 here, and if we look at data now, it only replaced the first match for p with an x. If you wanted to replace all of it, you will need to use a different function called str replace all. Now let's see, just to show that it's the same thing. If you do it like this, string equal initials, pattern p, replacement x, let's re-execute this, and it should have exactly the same result. Now if we go back, I'm gonna leave the short version because I'm kind of lazy and I don't want to type string equal initials, pattern equal p, and replacement equal x. If you're a beginner, you should probably try to maybe do it that way. Or if you want your code to be very, very easily readable by other people that may not know this particular function, you might also want to do it like that. If you want to save some characters, be my guest and use this. I usually use this notation. Now let's look at str replace all. So let's quickly look at this. And here we're gonna be replacing in the variable word, which we already have in our first data frame, right? We're gonna be replacing all p's with x's, and we'll see how that looks like. So str replace all, we're gonna pass as our string word, our pattern is p, and our replacement is x. Let's execute that. And now we have that we have replaced all p's with an x. So very easy to use. There's nothing else to str replace. You can use it in this way. Remember, if you just want to replace the first match, use str replace. If you want to replace all matches, use str replace all. Now next is two functions that come together, toupper and tolower, which are, oh sorry, there we go. Toupper and tolower, basically it translates characters in character vectors in a particular form, upper to lowercase or vice versa, and that's all it does. Also very useful functions, and something that you will use especially if you're trying to, like I said, join different data tables, where you might have, let's say, you might have in one of them light speed, it's all caps, and in the other data set, data frame, you have light speed, all low caps. But they are, this variable is shared by both data frames. In that case, an easy way would be to just transform one of them or both of them into, let's say, caps, and then you can later join it. Or sometimes you just want to not have low caps in your data frame because it might be confused with an L. You might confuse it with a 1, or an I might be confused with an L, depending on the font that you're using, and you can avoid things like that by just using all caps. So to do that, we're going to be modifying the column speed that we have in my first data frame, and we're going to be changing that to, actually you don't have it here because you created using the mutate. So that's something interesting that I forgot to mention. Once you have created something in a mutate, a new variable, you can use that variable within that same mutate. You don't have to go to another mutate. Sometimes beginners, they think like, oh, I just created this variable in the mutate. I probably cannot use it within the same mutate. So what they do is they type mutate speed equal light speed, then finish that mutate, then do a pipe, then type another mutate, and then do the modification that they wanted to do. You don't have to do that. You can just go straight to what you need and what you want to do, which is basically create the variable in that mutate and then immediately modify that variable in the same mutate call. This is a very nonsensical example because we could have just typed here lightspeed all caps and be done with it. But you know, we're learning here, so we're gonna do it the long way, or something that doesn't really make sense. So let's execute this code, and now we have lightspeed all in caps thanks to the toupper function. To use it, very simple. You say speed equals, or the variable that contains characters that you want to modify, then type toupper, provide the string, which in this case is speed. The variable speed contains the string, and then the function will operate. Mutate will operate this, will do this operation for every single observation in your data frame, so you don't have to worry about specifying, that you need to have it operate in the whole data frame. Now, what happens if you want to make those light speed into low caps? Well, you can use a function called tolower. So we're going to be doing that, and we're going to be doing that right after to see that you can also modify something that you just recently modified already. Remember, when you're creating new variables inside a mutate, remember to put a comma at the end so that you can let the mutate function know that you're creating another variable. If you don't place a comma, you will get an error saying something like, hey, unexpected symbol. That means that you probably forgot to add that comma. The annoying part is that it won't necessarily tell you. You see, it says error unexpected symbol in initial substring word initials, and you might be scratching your head like, what the hell went wrong? Well, it's pretty simple. You just forgot to add that comma. So if you see something like this, don't freak out. Just look if you're missing a comma, add that comma, and then you should be done with that. With that said, let's execute this. It's done, and now we have speed all in low caps. And yeah, I think there's nothing else to lower or to upper, right? We've gone through some very basic manipulation of strings, how to filter based on particular letters, or if it starts with an A or a B or any letter that, or any symbol that you can think of, if it contains more than multiple times a particular character with the use of the money sign. We've looked into complicated conditions using also str detect. We looked into mutate to create new variables, and we realized that those variables can be used also within that same mutate without having to create another mutate call. And we also looked into str replace, which replaces the first character that it finds, or str replace all, which replaces all characters for that letter. Now, thank you for taking this class again. I apologize again for the previous version. It was not working as expected. I tried to keep this video a lot shorter this time around. Unfortunately, that also means that some of the explanation that I gave before was maybe lost. Right? It was a bit quicker because I also didn't have to type as much. I usually like to type so that you can also type together with me while we're having those classes. So that was also lost in that session, in this lesson. But trust me, from lessons 5 and 6 and any other future lesson, I'll be more careful and make sure that the video is displaying as it should. And I'll also be typing together with you, which I believe makes it a little bit better. Yes, maybe a little bit slower, but definitely, while I'm typing, you can also type, and hopefully you don't have to hit pause on the video too many times. With that said, I once again want to thank you for your time. I hope you enjoyed this remake of lesson 4, and I hope that you continue to enjoy the course. If you like the work that I'm doing, if you like my classes, please like and subscribe. Tell your friends about it. I just want to spread the use of R as much as possible. Whenever we use Excel, there's the potential for lots of mistakes, very, very simple mistakes. And we can avoid all of this with R. We can also add a lot of the ability to replicate studies that we do with the use of R, which would be a little bit more complicated when using Excel. I can just code it once and then share it with you, and you would be able to replicate my study the exact same way. With Excel, you might have to, maybe write some documentation on how is it that you process your data specifically. Or you might have to use some kind of macro, which then makes the whole Excel sheet and the Excel file a lot slower. So I really think that R can provide you with significant value in the way you operate and work, and hopefully that translates into having more free time to do more exciting things at your work, or in general with your time. You'll cut those times that you spend remaking studies by a significant amount of time. Once again, I don't want to make this any longer. I know that you probably are quite busy and have other things to do. If you like what I do, please like and subscribe. And that's it. That was it for lesson 4 of our SamuRai lab. Class dismissed.